Well, good evening, everybody, and welcome to our first live moon tour. This is being brought to you from the Frank Bash Visitor Center at McDonald Observatory out here in West Texas. We're very, very happy to have all of you here joining us tonight. As I said, this is our first live program. I did want to mention that we are taking your questions in the YouTube chat as we go along through the program here. There are several moderators in there to take your questions. In addition, they will be saving some of the questions for me at the very end of the program tonight. We are going to do some Q&A to answer perhaps some of your more in-depth questions tonight. And like I said, we're going to look at some live views of the moon tonight. The sky is clear. It cleared about a half an hour ago. We have some beautiful views of the moon to show you tonight. And I want to tell you about where we are located out here in far West Texas. This is a view showing the summit of Mount Loch out here. This is our main summit on site. You can see there on the left the 82-inch Otto Struve telescope, which was actually the first telescope located here way back in the 1930s. It was the second largest telescope in the world at that time. On the right in the video there, you can see the 107-inch Harlan J. Smith telescope. That telescope was completed in the late 1960s, was number 3 in the world when it was brand new. And then in the distance on the far peak that you can see there, that is Mount Fulks, on which is located the 10-meter Hobby Eberly telescope, which is currently the largest telescope operating today. This next video, we're going to show you where we are located right now as we speak. This is a view of the Frank N. Bash Visitor Center at the McDonald Observatory. The dome that you see there near the middle of the frame is where I am located right now, broadcasting live on YouTube using our telescopes and about to show you the moon. The equipment we're using tonight, I wanted to say a few things about that for you. I know there's a lot of curiosity from amateur astronomers watching our stream tonight. We're actually utilizing 2 different telescopes, one to give us a low power view of the moon, and that telescope is a 3-inch Teleview 76 f6.3 short focus refractor. That will give us a wide view of the moon in which we can see the whole moon in one shot. The other telescope that we're using is a much, much larger telescope. It is a 16-inch f9 RC reflector, which will give us some very up-close views of the moon tonight. Both of those telescopes ride on what's called a mount. The mount is what allows the telescope to move and also allows the telescope to track on the moon or other objects as the Earth spins. The mount that we're using tonight is made by a company called Software Bisque. They are located in Colorado, and we're using one of their older workhorse mounts, the Paramount ME. Now look on the back of both of those telescopes that you see there. Look at the small devices that have cables coming out from them. Those are our cameras tonight. We have 2 of them, one on each telescope. These are made by a company called Point Grey Research, and we have 2 of their Flea model cameras. One is a Flea 3 2-megapixel camera. We'll be using that one for our low power views of the moon tonight. In addition to that, we have their Flea 2 camera, which is a 5-megapixel camera that we will use to get our close-up views of the moon. Now, I wanted to say that although this telescope system next to me is very, very nice and costs tens of thousands of dollars, you do not need a telescope like that to get superb views of the moon. In the current slide there, you can see my first telescope. I got this telescope when I was a young teenager. It is a 2.5-inch refracting or lens type telescope. And the inset image there shows a picture of the moon that I took with my iPhone pointing directly into a telescope. So you don't need a giant, expensive telescope to get a good view of the moon. And if you have that telescope, you can get some basic good pictures of the moon by just holding your smartphone up to the eyepiece and snapping away. Now, we've got a little bit of basic information out of the way. I want to show you a live view of the moon. On the left there is our full view of the moon, our low power view of the moon. I'm going to move that over just a little bit. It's sliding out of the frame a little bit. Let's get that centered up for you. Now we're going to come back in just a few minutes and look at more depth at this low power view, but I did want to start out by showing you a real live view of the moon. Well, I just thought, this is not really live. And it's not really live because, well, the moon is about 250,000 miles away. And so the sunlight striking the moon's surface and reflecting off toward the Earth takes a little bit less than 1.5 seconds to reach us here on the Earth. So technically speaking, this is how the moon looked about 1.5 seconds ago. Okay, that's our teaser view of the moon. Let's go back over to some slides here. I wanted to start out by giving a little bit of background information. And in particular, McDonald Observatory here has a special connection to the moon. And this goes back to the late 1960s. At that time, we had a brand new telescope, a 107-inch telescope that was mostly funded by NASA. Now, NASA had an experiment that they wanted to do. They wanted to attach a laser beam to the 107-inch telescope, fire a laser beam out of the telescope toward the moon. There on the left, you can see that laser beam leaving the telescope on its way to the moon, reaching the moon in about 1.5 seconds. Now look at that picture on the right. That device that you see sitting on the lunar surface is what's called a retroreflector. This is the one that was deployed by the Apollo 11 astronauts, who we will be talking about a little bit later in the program tonight. Now look at that reflector really close. You might be able to tell that it is subdivided into a number of elements that are called corner cubes. Those corner cubes reflect that laser light right back on its same path toward the Earth in Texas and McDonald Observatory. They went back inside the 107-inch telescope, and that allowed astronomers to measure the distance to the moon with very high precision. And that is our connection to the moon here at McDonald Observatory. A few moon facts for you. Now, we're not going to talk about all of this stuff. This is a lot of stuff to digest. I did also want to mention that this web stream is being recorded. So if you would like to go back and watch it later, you can always go back and step through the different slides that we had to learn a little bit more about the moon. I want to talk about the distance to the moon. It's an average distance. Let me go back. I goofed up. There we go. The average distance to the moon is about 240,000 miles. Now that says average because it varies a little bit, because the moon's orbit around the Earth is not a circle. It's an ellipse. And as the moon travels along its elliptical orbit, it can be a little further away or a little closer to us. And that definitely affects, to a small extent, the way that we see the moon from the planet's surface. Okay, now this is what I was going for. I really like this slide because it shows the 6 largest moons in our solar system. The moon is number 5 on that list, but here's a way to think about it. If you think about the size of the moon as a percentage of the size of the Earth, then our moon is the largest moon in the solar system because it is 1/4 the size of the Earth. All those other moons you see there orbit giant planets, and they're nowhere near 1/4 the size of the planets around which they orbit. The moon's composition. Have you heard some things about that? A lot has been said about that, and we've been to the moon. We've collected rocks and soil samples. We've analyzed their composition, and do you know we did not find any cheese on the moon, which is really unfortunate. But it turns out the moon's composition is very similar to the composition of the Earth's crust, with familiar things like oxygen and silicon and iron and other stuff. So we think the moon and the Earth had a common origin. There was a giant impact, we think, that created the moon, a lot of mixing between those two objects. And so understandably then, the composition of the Earth and the Moon do appear to be relatively similar. Early observers of the Moon included English astronomer Thomas Harriot. Now, he did actually observe the Moon before Italian astronomer Galileo did, only by a few months. You can see Mr. Harriot's drawing up there of the Moon, showing some of the big dark patches that we're going to see tonight. And you can also see Galileo's picture, or his drawings, showing some of the very same craters and other things that we're going to see on the Moon tonight. Speaking of which, let's go look at that Moon once again. Let me get back over here and get to the point I can show you the Moon. Let's try that one right there. There we go. There's that big, beautiful Moon again up there. Now, the Moon tonight is in a phase that makes it look a little bit like an egg. We're going to talk about Moon phases in just a minute. Just look at the Moon, study it for a moment. Remember, this is a live view. Probably the first thing that most people notice is the Moon is a sphere. The Moon is round. The Earth is a sphere as well. It seems like a pretty trivial thing to talk about, but it turns out if you're a very small object, like a small asteroid in our solar system, you can be whatever shape you want. Gravity forces you as an object, if you're above a certain mass, mass is kind of like weight. It forces you, gravity does, to be a sphere. If you try to have a giant mountain on you, Mr. Moon, gravity is going to crush that mountain and make you more into a sphere again. So it seems obvious, but yes, the Moon is a sphere. Look at some of the other features on the Moon. You're probably noticing several craters on the Moon. Impact craters have occurred on the Moon throughout its entire history. And in this low power view, several of those larger craters are visible. Look at the bigger, darker patches. Most of those are sort of like craters. They're called impact basins. They were very early impacts on the Moon that created much, much larger holes in the ground than do the things hitting the Moon currently, producing small craters. Now, those big dark patches are called seas. We know that they don't have any water in them. So why do we call them seas? Well, a long time ago, before astronomers had telescopes, they looked up at the Moon, just like you can go out right now, hopefully from your location, and see the Moon. And you will see those big dark patches. And people a long time ago looked up, saw the Moon, saw the big dark patches, and thought, not unreasonably so, that those could be oceans, water oceans on the Moon. But then Thomas Harriot came along and Galileo came along, and they looked at the Moon through their telescopes, and they saw details. They saw structures out in the middle of those seas. And so we understood at that point they're not bodies of water. But we had been calling them seas at that point for a long time, and so the name had stuck, and we still call them seas. Now notice the craters. Let's go back to the craters for a minute. Where on the Moon do you see the craters most easily? To me, I see a bunch of craters down here near the bottom, and I see some craters over here on the edge, and I see some craters, small ones right in there, and I see a lot of detail up there. Whereas if you look over here, you don't really see that many craters. And it's not that there aren't craters there, it's that the sun angle over here on the left side of the Moon, that sunlight is coming in at a very low angle to the surface. And if there's a little bump sticking up like a mountain or the wall of a crater, that's going to catch those morning rays and cast a very long shadow. And so there's just a lot more contrast visible along this line, which is actually the sunrise line on the Moon. That's where the sun is rising right now. And we have a name for that line. We don't generally call it the sunrise line. We call it the terminator, because it's where light and dark are separated by the rising sun or the setting sun on the other side. For a waning moon, that would be the sunset line instead of the sunrise line. For Observers of the moon, that's always the best place to look to see the most detail on the moon because stuff really stands out quite well. Now, think about the moon phase, the egg-shaped moon that we have tonight. Why is it not a crescent moon? Why is it not a full moon? Why is it not a half moon like we had a few nights ago? Well, let's go back to our slides. I want to talk to you about that for just a moment. I also wanted to show you this really cool picture. This was taken by the Apollo 8 astronauts. Now, they did not land on the moon. They flew around the moon. It was a proof of concept. They didn't land, but they took pictures of the surface of the moon, and they saw the Earth rising above the lunar landscape. Look at the Earth there, by the way. Did you notice? It's showing basically the same kind of shape that our moon is tonight. It's showing a phase and has a terminator along that bottom edge. All right, well, let's talk about why the moon goes through phases. We talk to people at the observatory all the time. We have been doing this for many years, and we have found that sometimes why the moon goes through phases can be a little confusing. So we're going to spend a little bit of time talking about that tonight. All the phases of the moon are shown on this slide, and some of them have names, like the new moon. The new moon you never actually see because it's too close to the sun to see. It's setting with the sun. And the side of the moon facing the Earth at new moon is completely dark. We can't see any sunlight falling on the Earth-facing side of the moon at new moon. But at full moon, we see just the opposite. The moon is entirely lit up. What has changed, by the way, between new moon and full moon? Well, remember that the moon orbits around the Earth. It takes about a month for that to happen. In the 2 weeks between new and full, the moon has orbited about halfway around the Earth and is more or less in between the moon and the sun. Not exactly in between, otherwise we'd be having a total lunar eclipse, but enough in between so that we see that fully lit hemisphere. About a week after new moon, or excuse me, several days after new moon, we have the crescent moon. The crescent moon is sometimes really nice to see over in the west after the sun goes down early in the lunar cycle. It's more or less shaped like a banana. See, I have a banana right here. I wasn't sure if I was going to get hungry before the stream tonight, but look at that slide. Look at my banana. It's about the same shape. Isn't that cool? Gibbous describes the shape of the moon that we have tonight, sort of that egg-shaped oval moon. Gibbous means more than half lit, but less than fully lit. And the phase that we have tonight, hopefully you can see it in your evening sky right now, is the one that we have circled there in yellow. Now let's talk about why the moon goes through phases. This is sometimes the difficult part. On this next demonstration, you're going to see two things happening. On the left, where it says from Earth, that's the lunar phase that you're going to see, given the moon's position that you see on the right. Over on the right is the Earth and the moon's orbit around the Earth. The sun is way over to the right side of the screen. It's lighting up the right side of both the Earth and the moon, and will continue to do that during this demonstration. It takes about a week to go from new moon to what we call first quarter. Now, we don't call it first quarter because we're seeing a quarter of the moon, because obviously we're seeing about half of the moon there. We call it that because the moon has moved 1/4 of the way around the Earth in its orbit. That's about 1 week. Then it takes about another week to go from first quarter to full moon, where the Earth is more or less in between the moon and the sun. And, you know, when people are out here visiting us from big cities for our Star Party programs, as they will be again later on, they always comment about how bright the full moon is from out here. And they're right. It is super bright. And sometimes they say something like, well, wow, that moon is so much brighter than it is where I live. And although it does look like that, the moon has a constant brightness. What makes it look brighter from out here is just the fact that our background sky is much darker than you would see in a city. Takes about another week to go from full moon to last or third quarter, where we're again seeing half the moon, but it's not the eastern side that we saw at first quarter, it's the western side. Still a half moon, just the other side. And then you can probably guess what's going to happen next, right? Yes, it's the fourth verse of the same song. It takes about a week for the moon to go from last quarter back to new. Now, this time period from new moon to the next new moon, or full moon to the next full moon, is about 29 and a half days. And it's a time that we call the synodic month. Synodic month, just the time to go from full to full or new to new. So the reason the moon goes through phases is two things. As you saw in the demonstration, half of that moon was lit up for the whole demonstration. The phase comes from what percentage of that lit half that we see at any given time. We only see a sliver of that lit half at a crescent moon, half at first quarter, the whole moon at full, the other half at last quarter. So really it's just the two things, which is one, that the moon is a sphere, it's sitting in space, one side of it's lit up, the other side of it's not lit up. The phase comes from what percentage of that lit half that we see, and that changes as the moon orbits around the Earth. Okay, well, and you will not be tested on this, everybody. We're going to proceed now to back to some live views of the moon for you. Let me get all set up here. There's our low power moon. All right, let me recenter it just a little bit. It's kind of jogged over a bit there. We're going to use our low power view to zoom in on a region of the moon that we now want to look at. We're going to proceed now, turn on a little crosshair for you. That will show exactly where we are looking on the moon, and you can see it's pretty much right there in the middle. Now I'm going to move the telescope again, and we're going to move to that upper left quadrant. We're going to talk about two large impact structures on the moon. That's just about where we want to be. Okay. Now what I'm going to do is turn off that little crosshair. And the image is going to disappear for just a moment. I promise it'll be right back. I'm switching over to our other camera on our other telescope. Wow, look at that. That's amazing. Now look at that image. You see how it's got a little waviness to it? That is coming from the Earth's atmosphere. As we look through different layers at different temperatures, that has a lensing effect that does cause the image to be a little shimmery, as we say around here. Now for this beautiful view, I want to give you a full screen view so that I'm not in the way. And what I want to talk about with you now is this region where we're looking, and you see that big crater up near the top of the view, and I'm going to jog the telescope over here just a little bit because I want to show you that other thing. Wow, over there on the left, look at that. That's amazing. Where we're looking now is a region in the northwestern part of the moon, and we're going to talk about these two large impact structures. The western and northwestern margin of the Sea of Rains, which is that big dark patch that you're seeing in here. We're only seeing about a quarter of it in here. But that is what we call the Sea of Rains, and it's marked by two prominent impact structures cutting the low mountains that define this portion of the Imbrium Basin, known as the Sea of Rains. Now, this is a multi-ring basin that was formed from an asteroid impact about 3.85 billion years ago. This asteroid is thought to have been about 150 miles wide and created the Sea of Rains, which is about 800 miles wide, about the same size as the state of Texas. When this asteroid impacted, it raised a concentric chain of mountains that we're seeing in our view right now. I want to direct your attention over here to this semicircular area. That's about half of an ancient impact crater. I'm going to jog the telescope over here just a little bit more. There we go. This area that you see on the moon right here is called the Bay of Rainbows. And shortly after the formation of the Sea of Rains, two large asteroids struck the low western hills that we now recognize in part as the lunar Alps. Somewhere between about 3.84 and 3.72 billion years ago, an asteroid struck this area, forming the future Bay of Rainbows and its rim that you can see there on the left, which is known as the Jura, J-U-R-A, Mountains. This crater measures 162 miles in diameter, and it was featured in a movie you might have seen, 2001: A Space Odyssey. Now, there's a big elevation difference between here and over there. And in fact, that change from the bay up to the highest peaks of the Jura Mountains here is about 13,000 feet in difference. Now let's look at this crater over here. This one is known as Plato, P-L-A-T-O, Plato. Following the formation of the Bay of Rainbows that we just looked at, yet another asteroid struck the present-day site of the lunar Alps, creating the crater Plato. It's about 63 miles across and is about 1.25 miles deep. Plato was much deeper than it is today at one time. About 3.6 billion years ago, lava, just like we see erupting out of the Hawaiian volcanoes today, began erupting in the center of the Sea of Rains and mostly filling up the bottom of Plato crater. That, folks, is one of my very favorite regions of the moon, and this is a very, very good phase to see it at. Now we're going to proceed down south from where we are now. We're going to take a leisurely trip down there. And I want to show you a couple of more impact craters, large impact craters. You'll see one coming into view right there. And I'm going to jog over here. We're going to catch another one, I'll bet, in the top. There we go. Right here. We have two craters, Eratosthenes crater and Copernicus crater. We're going to talk about these briefly. Let's talk about this one first, Copernicus. Copernicus and Eratosthenes, these two craters here, are both examples of what we call complex craters. The asteroid impacts that formed them excavated so much material so quickly, their floors basically bounced upwards, forming a series of mountains that in some cases tower over 1 mile tall. Notice the little dots in the middle of those craters. Those are those peaks that formed up about 1 mile tall from the bottom of both of those craters. Look around Copernicus. You see all those rays, this wispy material that goes out in all directions away from the crater. Bright rays extend away from Copernicus. That, excuse me, that is material that was blasted out of the crater, and then it was deposited on the surrounding landscape. Crater rays are deposited around all craters, but as the surface ages, space weathering darkens their appearance, and after about 1 billion years or so, the rays just disappear. They're not there anymore. So we can tell which craters are fairly recent by the ones that still have their rays. Now, that ray material from Copernicus was sampled by Apollo 12 astronauts. They landed just a little bit south of there, a little below there. And they determined that that crater, that impact crater that we call Copernicus, has an age of about 800 million years. And by the way, craters that have formed within the last 1 billion years or so are said to be of Copernican age, relating back to Copernicus crater. Now, Eratosthenes is similar. The sunlight on Eratosthenes is not quite as favorable as it is on Copernicus right now, but Eratosthenes is about 36 miles wide. It's about 2 miles deep. Now, it sits on top here of the Apennine Mountains. We're going to come back and see them in a minute. But because it sits on top of them, it formed after the Imbrium impact event, the big impact that produced the Sea of Rains up here. All right. That's a beautiful view there. We are going to go a little further south in our tour tonight. We're going to go down to a big dark patch on the moon known as the Sea of Moisture. It's going to be right along the terminator. It's coming into view right now. All right, let me arrange a few of my resources on this side. Let's pan down a little bit to the lower left. Now look at that big dark patch in the middle. This one right here. In fact, I might be able to make that look a little better for you. Let me see if I can bring out some of the detail out of those shadows for you. There we go. Now this big dark patch right here is another one of those ancient impact basins. It's called the Sea of Moisture, or Mare Humorum in Latin. The Sea of Moisture is very old. I mean, even for the moon, it's old. It's an impact structure that occurred between 3.85 and 3.92 billion years ago. It has a diameter of 264 miles, and it's about 1.5 miles deep. Lava eruptions are thought to have started around the time that that basin formed and ended about 2.9 billion years ago. The weight of all that lava, by the way, has produced compression faults in the center of the basin known as wrinkle ridges. These somewhat subtle structures that you see here are known as wrinkle ridges. Those are known as compression faults in geology. There's another type of fault, extensional fault scarps, and these are formed by sort of pulling apart forces. They formed along the shores of the Sea of Moisture. You can see a very good example of one right here. That one is 112 miles long. It's what's known as Rupi's Liebig. And it's basically a place where the surface was stretched and broke apart, and there's a difference in terrain between one side of that and the other side. There's a lot of elevation change, by the way, between the bottom of the Sea of Moisture and these tall mountains that you see over here, about 13,700 feet of elevation change. Now, you probably noticed this crater right here. This crater is known as Gassendi. It is a very old crater, what's known as a pre-Imbrium crater, happened before that Sea of Rain's huge impact structure was formed. It measures 68 miles across, right here, roughly across the diameter, 68 miles across. It's about 1 mile deep. It has a semicircular group of central peaks that you can see here that poke up from the surface of the bottom of the crater there about 1 mile or so. This little crater on the edge of Gassendi is called Gassendi A and is a much fresher crater. It's a Copernican crater, Copernican age crater, and it measures about 20 miles wide. Now you can tell that this happened after Gassendi did, right? Because if this one had happened in the other order, well, that would have completely obliterated this one. So in many cases, we don't know the actual age of the structure, but sometimes you can get relative ages by looking at what happened first. Okay, now we're going to go to another really cool part of the moon. I'm going to try to drive there in the high power view. I don't want to switch back over to that low power view just yet. We're going to do that soon as we head back up to the north. I want to take you down very, very near the south pole of the moon. There's a couple of pretty cool craters down here, and I'm going to adjust our image just a little bit to bring out a little more contrast. We're going to talk about two craters in this region that are Tycho crater, that's the one that you see near the top of the view there, and Clavius crater, which is this one down here. Let's talk about Tycho first. Now, when we go back to that low power view of the moon, Tycho is very easy to spot down on the southern end. It's very, very prominent in low power views, especially when the moon is near full. It looks sort of like the navel on a navel orange. Tycho crater right here is a Copernican age crater, so kind of newish. It can easily be seen by its prominent ray system, mostly at full moon, as we said. Now, there was a spacecraft that landed right about over here, just outside the crater on its northern slopes, and that spacecraft was called Surveyor 7. Surveyor 7 landed there on January the 10th, 1968. And cameras on board Surveyor 7 were able to detect lasers directed at it from California and Arizona long before Apollo astronauts placed those laser reflectors on the moon. Pretty cool. Tycho is 53 miles wide. It's very deep. It's about 3 miles deep. And the central peak in the middle is about 1.5 miles tall. The stuff that flew out of that impact, which we call ejecta, some of that was found to have been producing landslides near the Apollo 17 landing site, which is hundreds and hundreds of miles away. The space weathering exposure of those rocks in the landslide up there near Apollo 17 yielded an age for Tycho crater of about 108 million with an M years. Thus, we were able to date Tycho indirectly by simply picking up some of the stuff that flew out of it hundreds of miles away, bringing it back to Earth, and testing that to see how old it was. Now let's talk about Clavius. Clavius crater down here near the bottom of the frame. I can move down there a little more for you so you get a better view of that. Also gives you an impression of about how close down to the southern pole of the moon we are there. Because basically that's the edge of the moon down there at the bottom of the frame. Now Clavius is a much older crater than Tycho. It's about 152 miles wide, almost 3 miles deep. And one of my favorite things about Clavius right here, you might have noticed it already, it has a very interesting series of craters arcing across its expansive floor. Now, the distance, by the way, if you want to relate the size of Clavius crater, 152 miles, relate it to a drive you might have made if you live in Texas. The drive from Georgetown, Texas, to Waxahachie is about the same length of a drive as the width of Clavius crater. From the lowest point in the crater floor to these highest peaks that you see on the edge of the crater there, almost 15,000 feet above sea level. Wow, the moon is a fascinating place. All right, everybody, I'm going to make that view disappear again for just a moment. I promise it'll be right back. I want to go back to our low power view. And I want to turn on our little crosshair again so that we can go visit another site on the moon where Apollo astronauts landed. I'm speeding up the motion of the telescope so I can get up there pretty quickly. I'm also keeping track of my time here. I don't want to go too long on the moon so that we have plenty of time to do some Q&A for you. We're going to go up here and see some amazing mountains and visit one of the Apollo landing sites. All right, the image is going to go away for you. It'll be back. Transition over to our high power view of the moon again for you. It sure is a beautiful night here at McDonald Observatory. I wish all of you could be here right now. We do certainly invite all of you, as soon as we can reopen, to come out and join us for daytime programs, guided tours, solar viewings, star parties in the evening. It's our most popular program that we do. All right, we are in a region now where we have an Apollo landing site and a big group of mountains. These mountains I'm about to show you actually looked quite a bit better a few nights ago. And again, that goes back to the sun angle and how it can hide features, make them look more prominent or less prominent. I need to go up just a little bit more here for you. There we go. I want to show you the Apennine mountain range, which you can see right in through here. Some of these mountains rise up to almost 16,000 feet in elevation. And this big crater over here is known as Archimedes. We're not going to talk about that one per se. I just wanted to point out that it's there. It's about 50 miles wide or so. I wanted to direct your attention to a region of the moon, and it's always a little hard for me to spot this, but I'm going to do my best here for you. I think it's right about in here. And the reason we like this region, well, you know, there's a lot of really cool mountains that show up and a nice dark patch here, one of those lava flow regions, but it's a region where one of the Apollo missions landed, and it is tucked right up in here, I believe. And I want to show you a picture that was taken during that mission. Let me see if I can get the right one up here for you. There we go. Now we still have our live view of the moon over there on the left. And Apollo 15, the astronauts that were on the Apollo 15 mission are shown there. Alfred Worden was the command module pilot. In each of the Apollo missions, there were 3 crew members. 2 got to go down and walk. 1 had to stay in the command module, keep track of things up there, and be prepared, perhaps, to come back alone if something happened on the way down to the moon, or if the astronauts could not get back up from the moon to the command and service module. The astronauts David Scott and James Irwin landed near Hadley Rill, which is where we're looking on the moon here, near the northern end of the Apennine Mountains on July the 30th, 1971. And this was the first mission to use the lunar rover to extend their coverage across the lunar surface. 3 EVAs, that's technobabble for extravehicular activities, meaning they're outside the spacecraft walking or driving around. They did 3 of those, spanning a total of 18.5 hours, and they spent a total of about 67 hours on the lunar surface before they returned to the Earth a few days later. And again, that Apollo 15 landing site is right in there. Now, of course, we cannot see any of the hardware that were left at any of the Apollo landing sites with telescopes on the Earth, but there's a spacecraft called the Lunar Reconnaissance Orbiter orbiting the moon, has been orbiting the moon for about a decade now, that has high-resolution cameras. It has imaged Apollo 15 landing site, can see where they landed, where they walked, where they drove, and in addition to the other Apollo landing sites. So cool. All right, let me see what I have time to show you here. We don't have a lot of time left, but I would be very remiss if I did not show you the Apollo 11 landing site, where astronauts first landed on the moon in July of 1969. So let me go back to our view of the moon. You can see me there on the right. I'm going to switch over one last time to that low power view. It'll help me navigate more easily to get over there. All right, that's the right view. Here it comes, everybody. There we go. Now we're going to do this pretty quickly because we do want to get to your questions for sure. We're going to go over here to the south a little bit and over to the east a little bit. And right there on the crosshair is right where we want to be. So let me get rid of this image, bring up the high resolution image for you. Coming right up. Here it comes. There we go. Oh, that's exactly where I wanted to be. Now that's really bright, so I'm going to cut the exposure down a little bit for you. Where we're looking now is the very southern part of the Sea of Tranquility. This big dark patch right here is the Sea of Tranquility. And where the astronauts landed on Apollo 11 is right about here. And perhaps on a night when the atmosphere is a little more steady, there is a chain of craters there on the moon named after the 3 astronauts who journeyed there on Apollo 11. Aldrin, Armstrong, and Collins. I think the viewing tonight is a little too shaky to be able to see those craters very well. All right, let's see here. Oh, I did want to tell you a few things about Apollo 11 in addition to that. Of course, they landed on the moon on July 20th, 1969. Let me make sure I'm showing you the right picture here. Yeah, that's about right. They landed there July 20th, 1969. That's about 51 years ago. The descent vehicle was called the Eagle. The command and service module was known as the Columbia. They spent about 2.5 hours on the surface. They did one EVA on the surface. Were there for about 2.5 hours, collected about 50 pounds of rock and soil, and they put one of those laser retroreflectors on the moon for us. And in total, they spent about 21.5 hours on the surface of the moon there. Okay, I think I'll just leave that image. Well, no, I'll tell you what, let me give you that nice low power view again. Let's see if I can bring that up here for you. Takes a minute to get the camera on. That's not what I want. Hold on. I promise I know what I'm doing. There we go. Coming back up with the camera right now. Okay, I'm going to turn off the reticle. That's our crosshair there. And at this point, we have been in the stream for about 45 minutes. I would like to answer some of your questions. Let me jog the moon back in there so we don't lose it here over the next few minutes. And I'm going to bring up a chat window. My moderators have sent me some questions from you. Let's see, what do we have here? I need to go to this one right here. Okay, let's see. Brett asks, I have a question. The path that the moon takes across the sky in the summer, is that the same path the sun takes in the winter? And if yes, why? Very good question, Brett. It turns out that the moon does not take the same path in the summer and the winter. Now think about the moon for a minute. And in particular, let's just take the full moon. Let's take the full moon as our example because it's the most noticeable moon. Because the sun in the summer, at least in the northern hemisphere, is very high in the sky during the daytime, and because at full moon, the moon is opposite the sun, if the sun is high in the sky during the day, that means the moon is relatively low in the evening, at least the full moon. It does depend upon the phase and the time of year, the season and all that, but you will see some of the lowest full moons in summer and some of the highest full moons in the wintertime. When the sun is low during the day, that means the full moon is going to be up very high. And when you look up at anything in the sky, whether it's the moon or a planet or a star or a faraway galaxy, to some extent, how well you see it depends on how much atmosphere you have to look through. Down near the horizon, you're looking through a lot more atmosphere than you are when you're looking low, high. High elevation, little bit of atmosphere, low elevation, a lot of atmosphere. That provides more blurry views. Thank you for that question, Brett. Let's see. CJ Emerson says, are there weather changes on the moon? Well, to an extent, yes. I guess really the only weather phenomenon that you would notice if you were on the moon would be the temperature. Now, the moon does not have an atmosphere, and so the daytime temperature is about 300 degrees. The nighttime temperature is about minus 300 degrees. These are Fahrenheit measurements. And so because there's no atmosphere, that means there can't be any clouds to hold that heat in. It means there wouldn't be any weather systems, any rain or snow or anything like that. So yeah, in the sense that weather, is temperature is one measure of weather, then yes, you would notice a definite change from daytime to nighttime on the moon. Let's see. Who do we have here? Okay, Shannon R says, why can we have a close-up? That's Jose. I'm sorry, I was reading the wrong name there. Jose says, can we have a close-up of the moon to see the lunar modules? We did mention that just now during the stream, and the answer is yes. You can, if you go to a website for the Lunar Reconnaissance Orbiter. Go to a Google search and put in the letters LRO for Lunar Reconnaissance Orbiter. You can go there and visit all of the Apollo landing sites. We could never see them from the Earth because the Earth has an atmosphere. It blurs out tiny details like that as seen from Earth, but definitely the Lunar Reconnaissance Orbiter can and has seen those landing sites on the moon. Let's see. Moni Smith, apologize if I'm mispronouncing your name there. Her son is Max, and Max wants to know how long your commute is to work and what animals you've seen on your drives. Oh my goodness, Max. I live about 40 miles from the observatory here. I live in Marfa. I live up here part of the time. I have a house up here at the observatory, but I also have a place down in Marfa. I don't have much of a commute if I'm just going home from here at the visitor center. About 300 yards that way is my home here. But if I'm going all the way down to Marfa, my commute is about 40 miles one way. And animals that I've seen, oh my goodness, I've seen deer, I've seen javelina, I've seen badgers, I've seen elk, lots and lots of things crawling across the road like tarantulas and snakes and lots of bunnies. There was a few years ago when, especially in the wintertime, we get a lot of bunnies out here, and I get a little bored on that trip to Marfa sometimes. I'm still paying attention to the road, I promise. But I was counting bunnies one night, and I counted 54 rabbits on my drive just between Fort Davis and Marfa. And I promise I did not hit any of them. Yeah. Well, let's see, folks. We are at this point out of time. Thank you all for uh, giving us your questions tonight. Thank you all for tuning into this stream and for giving us 45, 50 minutes of your time tonight. We very much appreciate your joining us. Once again, we will reopen the observatory and the visitor center when we can, and we do not know when that is, but it will be eventually, and we invite all of you to come back. If you've been here before or come here for the first time, we have an amazing array of public programs that you can do here, led by myself and all of my colleagues, whom I would like to thank very, very much tonight for their support in getting me up and going on doing these YouTube live streams. Again, thank you all for being here tonight. We appreciate your time, and keep your eye out on this channel. Please subscribe to our YouTube channel and keep us in your thoughts, because we will be doing more of these programs as time goes on. In addition to deep sky programs about the moon, we have big plans for the future for our live streaming on YouTube. So thank you all again for joining us tonight. Again, we will see you soon. Goodbye.